Okay, that's fine. Just have 1,000 webcams plugged into the computer. All right, so you probably noticed I don't have my webcam working, so I'm sorry. You're probably tired of looking at me anyway. I'll get it fixed by next time. Okay, so last time we focused on the skills that you would need to finish the Chapter 9 assignment. Now we're going to take a look at Chapter 10, which is introducing you to a very important part of object-oriented programming principles, which is inheritance. Pulling up the chat here. All right, that's set up. Okay, so what is inheritance besides money you get if from a distant relative? So we'll just take a broad overview first. So we'll focus on describing inheritance, what it's used for. All right, so we've been creating our own classes, but you can also extend classes, and you'll see if you've had a programming class with me before, you've probably heard I talk about something called dry, don't repeat yourself. And so if you ever find yourself programming and you're doing something repetitive in the code, there's probably a tool to help you skip that. So you probably haven't created a lot of classes up to this point, but if you do, if you have, you may notice that a lot of them may be similar, all right, with slight differences. So inheritance can be used to stop you from repeating yourself. All right. I guess we're also going to look at the protected access specifier. Now I wonder if that's considered an access modifier too. I'm not sure. Okay. And then we'll also look at overriding class members. All right. So how can we give classes? Well, we'll get there. It doesn't make sense now. Okay. We'll look at basically the structure of how C# sees an object, and you'll see how every class you create will inherit the members of the object class. All right. We'll also look at abstract classes, which are a little complicated, so we'll look at that in more detail. We did talk about interfaces before, and so in here we'll take another look at that. Instead of just using an interface, we'll actually create one and use it, so that'll help you understand where that comes from. And let's go ahead and start here. Just get rid of the notes here. I don't need notes. Okay. So, what is inheritance? That last one looks pretty nice, huh? Makes programs easier to write. You'll get there. Object-oriented programming, there's a lot of pieces to it, and you have to learn what the pieces are so that you can do things efficiently. Okay. So here's their definition of inheritance: applying knowledge of a general category to more specific objects. And so they have this. I feel like this is a terrible example. Similar to how your blood type and eye color are the products of inherited genes. I think a better example would be cats and dogs are animals. Or trying trying to think of other examples we've used. Anyway, let's go with that one for now. The advantages here, it saves time, so you're not repeating yourself as much. Reduces the chance of errors. When you repeat yourself, you have additional chances to make mistakes. And if you use inheritance, the code you write will be in one place, and you don't have to go and change it. If you change it, if you ever find yourself needing to make a change in your code, and you have to do it in multiple places, there is probably a way you can avoid that by using some of the things we're going to look at here. In previous classes, you would use a for loop, right? We still have those, but use a for loop to stop from repeating yourself, and then you just have to edit that for loop. And then we also looked at functions in other classes. So now we have classes and methods. So methods are just functions of an object. So we can use these tools to be more efficient in our coding, which has wide-reaching effects on the entire program. Okay, so let's take a look at this example here. We just have an employee class. Okay, class employee. We need to remember to capitalize our classes. Here we have a field of salary. Zoom in here maybe. My touchpad will work with me. Okay. We have remember, this is a field. We talked about all of this, but I'll re-mention it because it helps to have that repetition. Fields have they're basically local variables to the class, and so in that case we need to use lowercase. Here we have a field. Remember, that is how we are letting other parts of the program, other classes, access the data is through fields. All right, and then right below that we have, this is another field, but they're using custom gets and sets. Okay, the get is returning the field. All right, and so since this I'm sorry, it's returning the field. This property it has access, even though it's private, to this field because it's within the same class. All right. But the reason they have this here is for the set method. So they want to do a little data validation here on the input of, or the arguments for creating this class, or setting the property of this property. But lots of terminology to keep track of. All right. They are creating a constant within the set method. And they're doing that so that you can set a specific value here. Have you seen this before? They're setting a double to the value of 15_000. Have you seen that in C#? Okay. We'll have to take a look at what that is. I wonder if it's a typo. These textbooks do have typos, but we'll see if that's something important, I guess, later. All right, and then they have an if statement. This is where they're doing the validation. So here they don't want values less than 15. I'm assuming this is 15,000. They don't want values less than 15,000 inside of this salary field. So they have an if statement that checks whether the value is less than the minimum that we set here. And I wonder if it would be, no, it's probably better to set it in here in case you want to use min other places. So never mind. All right. And then so if you do put in a value less than 15,000, it'll just use 15,000. So it just won't let you put in anything less than 15,000. If you put in something equal to or greater than 15,000, it will use whatever you pass in. All right. And then we have another method here that will allow you to return a string using some of the variables in here. Okay. They set up the salary, but they don't use it in this. But you can access it from the property if you need it for whatever reason. So just going through the code and talking about what these different pieces are, it's important to understand what they put in here and why. And then once you get further down the road and you understand things, you could probably come back and pick this code apart. It's not hard to do with textbook code. Okay, so what are we going to be talking about in inheritance? What terminology do we need to understand? Because the reason you need to understand the terminology is so not only so when you do research yourself on how to fix things, you know what to search, but also if you're talking to other professionals in the field, you guys can know what you're talking about. You can save time trying to explain everything. No, I have no idea. Good question, though.
It logs to 150,000.
Really?
Yeah, but that's not what it says it's supposed to do. It's supposed to be used as a digit separator, like a comma, but in code.
Oh.
So that you can read it easier, but it's actually logging to 150,000 rather than 15,000.
Weird. Yeah, I don't know what place would have a minimum salary of 150,000. Maybe I'm just used to living in this area, right? Okay. 15,000. Yeah, I don't know. 15,000 sounds really low, too. I guess that's more believable than... I guess they're both believable numbers. Okay, anyway, terminology for inheritance. And I'm going to look ahead a little bit here because just reading these terms doesn't make as much sense. But if we diagram them, I think it'll make more sense. So I'm going to go ahead and open a draw.io so we can kind of have some context of what we're looking at. And I never bookmarked this site because it's just the name is so short. Okay. I'm actually going to put this in the class so that way I can find it later. So this is going to be inheritance diagram. And pictures are worth 1,000 words, and they can really help understanding. So I know some of you folks are probably avid readers of the material. That's good way to learn. I can't do it that way. Some of you probably like to watch people do it, and then you can copy it, and once you understand the basics, you can kind of branch out from there. That's how I usually learn. And some people require, pictures to help them understand, almost like a mnemonic device that you can think about to help you organize your thoughts. All right, so let's talk about these, and then maybe we'll make a diagram. So the base class. This is going to be the class that other classes will inherit from. Okay, so you can think of it as a parent. So that would be at the top. So we can imagine this as our base class. And let's zoom in here because you'll probably need a magnifying glass to see this. All right, so we have our base class. That is where we're going to start, and then we'll create classes that inherit the members of this class, and that allows us to avoid repeating any members that we're going to want to use over, in multiple classes. And if we need to change that code, or if we need it to do something different, we only have to change it in the base class. Because, we're not going to look probably at too many examples where we have a very large hierarchy of classes. Can you, in your work, Scott, have you worked with or creating classes that go down very deep in inheritance? Or like one level or 2 levels probably at most? For most things, but you may encounter something that's more complicated. Generally, if you need more levels than 2, I'm imagining you're doing something fairly complicated. It could involve like networking. That has so many different things that are related. Or communicating on the web. Usually people have created stuff for you there, but you might have to edit it, so it's helpful to know. Okay. All right, there's a derived class or extended class. All right. And so you can think of this as a subclass. This is the one that copies the members from the base class. And this is important. The derived class is a instance of the more general base class. And when we look at the object class, we will see that everything inherits from that class. So I prefer to call it extended class for this example, but I guess we have 2, so we can call it derived class too. One of the fun things about this is learning 12 different terms for the same thing. All right. I always tell people it's a work in progress. Interesting. I wonder if it's changed.
Well,
or they're.
introduced in C#7 and trying to figure out what route to use it.
Oh, okay. Yeah, they're probably using a. That would be something, huh? Yeah, keeping track of the version of the programming language you're using. That's. I haven't encountered that too often. All right, ancestors. A list of parent classes from which a child class is derived. So, let's say we created these classes as subclasses of the base class. So, this might help too. We'll say base class is maybe the animal class. And then these other ones would be dog class and cat class. Oops, I don't want to put class in there. Okay. So if we had an animal class, we could create subclasses for different animals. All right. But let's say we want to look at whatever the animal class inherits from. That could be considered the ancestor class. Okay, so this animal class is an ancestor of these two. This is an ancestor of animal. and this may be organism. And we might have another class that extends from that that isn't animals, and maybe we could call that bacteria. And to be topical, let's go ahead and put in viruses, because they are different. They're very different, actually. All right, and I am at the top of my diagram here, so let's move all of this down. Okay. I always forget where the zoom is. It's easier if I just use this. Okay. So we could have this as our ancestor of all of these, but it's also the base class for bacteria. Come on, come on. There we go. The animal class, and the virus class, and then maybe the virus class has a class of maybe different strains of viruses. You have to be careful because let's say, and this is where this animal example may be a poor example in programming, because if the animal can do everything that we need cats and dogs to do, we don't need to extend those classes. If dogs and cats are going to do very different things, different enough that we couldn't include it in the base class, or it would be something that we repeated in the base class, we would want to extend that out. So here, let's do, COVID is a virus. And in the beginning, I remember people, we called it, now we call it COVID because everyone's tired of saying COVID-19. There was another name for it too. Oh, the coronavirus, right. And then Corona, the beer company, went out of business, or maybe they shut down because people thought they were going to get the coronavirus from drinking Corona beer. And let's do another pandemic that was much smaller, and I don't even know if it qualifies as a pandemic. Maybe it does. Compared to this one, maybe not. I think H1N1, was that the swine flu? Okay. All right. And so these could be classes that inherit from here, but ultimately there's some sort of organism. All right. So here's an example of a bunch of classes that you could create if you were going to have objects represent these different things. Okay, did I miss anything in here? Inheritance is transitive. A child inherits all members of all its ancestors. So what does that mean? That means if the organism class can die, then every class that extends from it can die. This is very negative. What else can organisms do? Reproduce. There we go. If we want all of these things to be able to reproduce, then that would be, you could have that in the organism class. All right. We have bacteria like on lockdown. It's a joke now compared to viruses. Viruses are, if you're stressed out about COVID because you don't understand what's going on in terms of the biology behind it, it's very interesting to take a look at how a virus works. So, something to think about. All right. And really understanding more about something can help you alleviate stress and fear regarding it. just make sure you're using reputable sources, because there's a lot of fear-mongering involved with this, because it makes someone money. All right. I bet the Corona Beer Company wishes that they would have just called it COVID. Man, what a bummer for them. Okay. So extending classes, how do we, in the code, how do we tell it to extend from the base class? All right, so you just have to include a colon between the class name of the child class and the name of the base class. So here we have a class of commission employee, and that is a subclass of employee. So we include the colon here. And so we could have other employees like hourly employee or contract employee or something, you know. I won't diagram that. You get the idea. So here's our giant code here. Let's see. This is in our main, so let's see what they're trying to do here. Oops. Where's the zoom button? Let's use that. I got this laptop refurbished, and the touchpad, one of the most important parts here, does not work very well. Okay. Let's start at the top here. I'm going to zoom in some more, because I want you to be able to see this. Okay. So what are we doing here? Right here. Employee accountant. We're declaring a variable of type employee. So that means we are using the employee class, and we're saying, okay, create a new employee, and it looks like they didn't create a constructor, or maybe they did, I don't know. It didn't show it before. This, I think they're saying this is the entire class here. Just a one field. Okay, they're very focused on just showing one part, which I think is good. It's a lot harder when you throw it all together like this. Okay, so we're just creating two objects here. Remember, whenever you use the new keyword, you're telling the computer create space and memory to hold an object. And then and I'm going to keep saying this because it's paramount to understand when you're moving on and you're actually building something. If you don't understand this, it's going to be very confusing. So when I create an object in memory, what this returns is the address to that spot in memory, and that is what gets stored in the variable, that address. Okay, and so that's our handle that lets us manipulate that object or look at it, this variable, which means you can move this and store it around in other variables, and the object will still be in the same place in memory that it has the address for. Okay. Here we are creating some commission employees. All right. We have accountant and programmer are employees, and we have salesperson 1 and 2 are commission employees. So we're creating 4 objects here. Then they're setting all their fields to different numbers. What does it say here? In the output that these high salaries are restricted. Okay, so they're trying to hide. That's weird. Okay, we'll see why they're doing that here in a second. Okay, so we're just setting those fields, and then we're just outputting everything, it looks like. Right line. Yeah, they're just outputting all of the stuff inside of there. So I'm not sure if they're trying to make a point here, what that point is. This is how you would do it if you wanted to just create some objects set the fields manually and then print it out. I don't see anything. What is this? Salesperson1.salary.toString C. Did we have a toString method in there, or is it using the base one? Yeah, I don't think we had that. Okay. Anyway, I'm not deriving any new information from this. Let's move on. Oh, here's the output. Okay. Accountant 123, yada yada. And so let me, are they, okay, is employee an actual string, or are they pulling out the class there? Get greeting. What was the get greeting? I think that says hello, I am employee. Okay, now I understand what they're trying to show. So the employee class has a method called get greeting. All right, and then down here, all this has, all the commission employee has is one field. It doesn't have any methods defined in the class. Okay, so how are they using, let's follow through here. We're creating two commission employees that do not have a specified greeting method, and that's salesperson 1 and 2. And then so if we look down here, salesperson 1 dot get greeting, so they're asking for a get greeting method inside of commission employee. Okay, and we know that's not in there because all it has is this. Okay, but this part right here, the colon employee, because we're inheriting from the employee class, we also get the methods of the employee class. And I guess I should have noticed this too, but we have ID number and salary properties inside the employee class. We don't have that in the commission employee, but by adding it, by extending this class employee, by creating another class commission employee, tying them together, it has all the methods and fields from employee. So if we have 5 classes that extend from employee, we don't need to give them an ID number field. We don't need to give them a salary field. And that salary field has extra code in the set method. If we just created just base classes for all the employees, and we wanted that salary code in the setter, we would have to put that manually in each one. And if maybe the number changed from 15,000 to 20,000, now you have to go in and change it in all those classes. So DRY, dry, do not repeat yourself. If you find yourself repeating, and in this class, learning object-oriented programming, I'm not sure if there's anything higher that helps you not repeat yourself than classes. I mean, other than using other code, what is that called? Is called a library in C#, right? Okay. And if you've taken other programming classes, if you've taken the Python class, we have Python packages. When we build, in the capstone course, when we build a web app, you have APIs that you can use. And those basically help you not reinvent the wheel every time you try to do something. All right. So again, I see some people are in the live stream here in the chat. So if you have any questions about anything, Chapter 10, Chapter 9, any of the homework, due dates, whatever, anything about the class, bring it up. This is your chance to have me to yourself, I guess. All right. So using protected access specifier. Let's see what this is. Okay, so we already know this. We just looked at this. Derived classes inherit all the data and methods of its base class. All right. I don't know if I would call it data. Maybe that's fine. Just remember that's your fields and properties. I feel like being more concise on that is important. Okay, so private data and methods in the base class are also inherited, but they cannot use or modify private data and methods directly. What does that mean? Well, we'll see. A protected data field or method can be used with its own class or in any classes extended from that class. So that's different between private and protected here. So with protected, the inherited classes can access. With private, the extended classes cannot modify private data and methods directly. Now, with that in mind, let's take a look here. Protected data fields cannot be used by outside classes. So only your inherited classes can use this. So if we had, let's go back to our diagram here, and let's add another thing. So I'm just going to create a new section of here. So let's go games. And we have board games and video games. All right. I really like this tool for diagramming because you can do this. There we go. And just for clarity, I better move this over so you don't think there's some kind of overlap here. I want to be clear on this because it is complicated. In terms of what you've learned so far in these courses for the program, this is probably one of the higher level ideas that you'll learn. It's not hard to learn, it's just more complicated than what you've already seen so far. So I'm just saying focus on it. That's why there's two classes involved in here. Unfortunately, apparently in the first one you don't talk about objects, so that's confusing to me. All right. So if I had a protected field here, and they've got a nice thing here, I think you can, nope, not this one. Let's make our diagram more specific. So let's go to, I believe they have some actual, here it is. We'll make this the organism class. And let's say it has a protected method of reproduce, because we talked about that. Okay. And let's get rid of these. Let me do this. Let's see. I don't think so. I don't like the shape that is creating. All right. Let's move these up to match. And as I'm doing this, if you understand what's going on, you're probably like, okay, move on. But just keep in mind, there are other people in the class that learn differently, so try to do it do these demonstrations in a few different ways so that we can help the most people. All right. This touchpad will cooperate. All right. So the question is going to be, can... All right, this is driving me nuts. Oh, I gotta go around the outside here. Oop, there it is. Gotta go down further. Wow. Okay. Well, I think you get the idea. Let's fix it, though. Manually, I guess, at this point. And do that there, and let's do... This is a good example of how to use this, too. Not a circly one, just regular. Oh, well. Oh, rounded, we want sharp. There, now it's fixed. Oh, but we don't have an arrow. And now the arrow is going backwards. All right. Come on, work with me here. Perfect. There we go. All right. So now that we've forgotten what we're supposed to be looking at anyway, let's reiterate it. Whoop. There we go. So we're talking about the protected access modifier here, and we have it on it's a method inside of the organism class called reproduce, and it's protected. Can the bacteria class reproduce? Can it call that method? If I had a bacteria object, could I call the reproduce method? Because this is a direct ancestor. Okay. What about dog? Can it reproduce? All right. Based on the fact that reproduce is protected. It's not the direct descendant, but it is a descendant of a descendant, right? A dog is an animal that's an organism. That's just how we have it set up. So, what about video games? Could they use the reproduce method? Or board games? Or games? What do you think? So, we'll do this. We'll set this to green. Actually, wait. Let's use some color blindness safe colors. Color blind safe colors. I have had colorblind students before, and I usually use red and green to denote how things are related, but that is not a good choice for colorblindness. All right, so and there's a ton of different types of colorblindness. So let's use yellow and I guess pink. Yellow and pink. So we'll do a yellow for reproduce. Oh, that's not good. Let's give it a shadow. Or let's just give it a darker yellow. That'll fix it so we can actually see it here. Okay. Well, now you can't tell it's yellow. Slightly lighter. Can we see that? Okay. Let's just get rid of the grid lines because that makes it harder to see. I don't need to measure this. All right. So we're going to identify which of these classes can use the reproduce method and which ones cannot. All right, if it's protected. So you've had enough time to think about it. Let's see if you were right in your guesses. And we'll do it this way. Because I'm not going to change the color of each one, we can take this and we'll do a little arrange to back. Stick that in the back. We will do this. Stick this here, and then let's add a fill of that yellow color. That way you know all of these classes can reproduce, okay? And we'll use the pink to show the classes that don't, though process of elimination, probably you can figure out which of these over here do not use or cannot use that method. I just realized after I did this, you can't read it, so we'll keep it there. You guys know that if I created an organism object, it can reproduce because it has the method inside of it. Okay, so I just assume you will know that because that's what we learned in the very beginning. If we add a method to a class, whether it's protected or private, it can use that method. Or field, you know, it doesn't have to be a method. Okay, so can any of these three classes use that method? And I know I like to do, if you've had class with me before, you know I like to do trick questions in person, but not on a test or anything. So in this case, I'm not doing a trick question. I'm trying to be as direct as possible because I don't want to complicate it any more than we need. None of these can use it in the current way we have it set up. All right, and now I'm not allowed to ask the students if they are colorblind, but if this helped you, you know, people forget about colorblind people because it doesn't affect very many people outside of the person with color blindness. So it's hard to be sympathetic enough to remember that people are colorblind. Anyway, all of that to say, where's the zoom? Got to zoom out. We have too much on the screen. Okay. All of that to say, the protected access modifier limits the use of a method or a field, or I'm sorry, method or property to the descendants of the class. Outside classes cannot use it. And that's true of private also. Well, the last part is, but if we had private data and methods, then we cannot directly modify those. So we can allow the children to use those. So if we want the children classes to be able to use the fields or methods, but we don't want outside classes to use them, we use protected, or to modify them. And then all of that, so much time spent on that, and then the next part right here. Protected data members should be used sparingly. All right. And then there's a lot of pitfalls you can fall into in object-oriented programming if you use things in a way you don't understand, or you misunderstand how they're meant to be used. So classes that depend on field names from parent classes are said to be fragile because they are prone to errors, but it doesn't say why. Okay. So here they have created a protected, this is a field, okay? Created a protected field of salary. So our commission employee will be able to manipulate that. So if we look at the commission employee, we can modify that field from the child class. All right. And here they're just showing that it works, I guess. All right. So let's say we're going to talk about overriding now. Let's say in our example here, this is actually, I'm glad I chose reproduce. This is a really good example because different organisms reproduce differently. Okay, so it would be a good method that to override. So you can give it different. Basically, you can modify it and change what it does. Okay, so bacteria. Don't quote me on this. I believe they asexually reproduce. I know viruses do. Viruses actually kind of like a biological DDoS attack, honestly. But what they do is they inject their viral DNA or RNA or whatever it is into your cells, and then it uses the material in there to reproduce itself, and then when the cell dies, it launches out and hits all your other cells. This is why they're so insidious. They're very tiny. You could fit a million, a large amount, probably over a million. The scale of things on a small size is hard to imagine, and I'm not going to be able to describe it in words, but there is an awesome video of an electron microscope zooming out from a penny, and electron microscope penny zoom out. All right, I remembered. All right, let's take a look at this real quick so you can understand the scale. Okay, so there we are. Zooming out. They laser etch something on the penny. They're zooming out. They so you can't even see what they etched initially, and then they etch Abraham Lincoln on the penny, and then if we zoom out, you can see how small that is that they did. So you can't see, if you're looking at bacteria, you're not looking far enough to see viruses anyway. So it's something very small. Okay. Anyway, moving on. All three of these are going to reproduce differently, and then even different animals reproduce differently. All right. We have dogs and cats, but insects are weird. They're so old in terms of animals that have existed. I don't even think you probably wouldn't even categorize them under animals. I don't know the scientific definitions of that. Okay, anyway. This method would be something we would change and probably need to change within the classes. So to do that, we would use this idea of overriding. All right. So here we begin introducing this idea of polymorphism. All right, we're not talking about Harry Potter. I'm not sure if that's even popular still. People of the newer generation. So that joke may have flopped. Anyway, it was a terrible joke. Okay, so what is polymorphism? Here they define it as using the same method to indicate different implementations. And that's a mouthful, right? So basically, we see this in overriding constructors. We've done this before, and that's considered overriding, right? Within the same class.
What?
If I'm overriding a method within a class, within the same class, is that overriding?
No.
That's what? What is
Overloading.
it? Overloading. Okay. There you go. So we've overloaded methods, but now we're overriding. And the difference is when you're overloading a method within the same class, it's only going to change that class. And when you override, it'll basically, the original method still exists in the base class, but you're creating new, it says different implementations, so it's doing different things, like the example that we were looking at. Viruses reproduce in the way that I described. Let's see. I'm trying to avoid talking about how animals reproduce, is what's going on, because I don't think I need to tell you that. Okay, so yeah, cells or bacteria grow and then they split. Okay, and bacteria aren't all bad. We couldn't live if we didn't have bacteria, which is unfortunate. It makes us very fragile. Okay, that's why when you take antibiotics, you got to worry, because it's killing your good bacteria potentially. So overriding. So if the virus was going to override the reproduce method from the organism class, let's just imagine the organism class, you probably wouldn't instantiate something like this, which we'll get to later. This is a good example of another type of class that we're going to look at. But let's imagine we would instantiate this. So we would create objects from this, and the reproduce maybe would just be increasing the like let's say it has a population field. Let's do that. So before the method, we'll go and list the field, which would be, got to give it a type. Let's make it public int. What did I just say? Population. And then it's got the get and the set, you know, all that stuff in there. Okay, so we'll say, okay, apparently I messed it up. Okay, well, I'll fix that later. I don't want you to have to watch me troubleshoot diagram building. So I'm going to change this color too, because it's not protected. Back to black. We'll see if it lets me keep these different colors. Good. Okay. Nope, it doesn't. All right, well, I'll remember what these colors mean. So let's say let's say the reproduce method just increases the population, doubles the population or something. But let's take the virus one. The virus, for example, it needs a very specific environment to reproduce. It needs cells and a host cells, we call them. All right. And so one virus can generate a lot very quickly. So maybe how it manipulates population would be different. Instead of doubling it, maybe it takes it time, or multiplies by 1,000 each reproduction. All right, and then bacteria, that one would just double. If that one just doubled, then we don't have to override the reproduce method. But since the virus does reproduce differently in a way that we can't use the base reproduce method, we would override that. Okay, so let's look at the code and how to do that. If you're in the chat and you can hear me and you're watching this, please give me an honest message about whether or not this is sinking in at all, because I may need to slow down and go back a bit before we move on. So be honest, and if you're embarrassed or you don't want to say it publicly, just send me an email later and just say, hey, that lesson was I had no idea what was going on. I got nothing from it. Okay. Or maybe you can just give me some feedback. You're going too fast, you're going too slow. All of that stuff is helpful, and I definitely don't take it personally. So let me have it. All right. Overriding versus, this is not overloading. I do so few, I develop things and I do examples of non-object oriented programming. It's hard to keep track of all the terms. Overriding. Though to be corrected in the video will help me remember that. Okay. So, how do we do this? Overriding base class members. So how do we change the reproduce in a different class? That is a descendant. So here we specify the method or the field, and you just include this word here, virtual. And with overloading, so when you're overloading a method, not overriding, when you're overloading a method, and I'm saying it so many times so that we can keep it straight. So when you're overloading a method, it requires you to provide a different signature for the method. So that's usually in the form of different parameters. Overriding, you use the same, you can use the same signature. Do you think in a overridden method, no, you wouldn't use a different signature. You can. Oh, you can't? Okay. Okay. So this should really say, well, it says a virtual method is one that can be overridden. Okay, that's true. Doesn't have to be. By a method with the same signature in a child class. So it says a method with the same signature. So it has to be the same. This is a very important distinction, and they probably go into more detail in the textbook on that, but learning this from a textbook is torture, probably. Moving on. So here they've overridden a property. So the reason they've done that is you may have changed the get and sat methods inside of that. And so here you can provide different implementations. I'm going to keep using that. Basically, you can change the code within those methods. Okay. A derived class can override, right? We just talked about that. That's the whole point of what we've been talking about. But it also says, and hide methods and data from the base class. Okay. You are not required to override methods or properties in a derived class. So if your base class has reproduce method and it's good enough for all your base classes, you don't have to override it. You could just use what you've already created in the base class. Which it says here, the derived class can use the base class version without having to override. You don't even have to put a reference to it, other than making sure that you extend the class from the base class. All right, a base class member that is not hidden by the derived class is visible in the derived class. So, a base class member, what are members of a class? We have fields, properties, and methods that we've looked at. Fields and properties store data. Methods do everything else. They give actions or abilities or struggling to find a better word for that. A method does something. Usually with the data, but it doesn't have to be. So what does that look like? Well, we saw it here. They made the virtual property of credits in the base class. So we set in the base class, we set it to virtual. That means it can be overridden. Okay, and then in the in the Descendant class of demo students, no, that's the name of the program. What are they doing here? Paying student is a student class. Oh, they have the free student class. They didn't even show that, so I guess we just have to assume that the free student class, make sure I didn't miss it, is extending the did I skip it? Okay, polymorphism. Now I'm seeing stuff that I might have missed. What's going on here? There it is. Okay. So here, I guess, scholarship student is the class anyway. I'm looking at the variable name. So in this code here, we did see that the student class has a virtual property, sorry. I should just stop saying field. You don't use fields as much as you do properties. Okay, right, so in here we have this public property, but it's also virtual, so it can be overridden. And so I guess we are to assume that the scholarship student has or is descended from student. Okay, and so free student here, this variable is our it's driving me nuts. Free student is our scholarship student. Okay. And so they're not showing that it's even being overridden here. So I wonder if they're missing a slide in here. I wouldn't put it past them. Okay, so I guess, again, we can just assume. We'll see a better example later. we can assume the scholarship student class has overridden the student classes man, this must be hard to follow if I can't even do it. All right, credits field. So let me say that again. See if I can say the whole thing. All right. The scholarship student class, which is a descendant of the student class, is overriding the credits property from the student class. And we can't see what it's doing, but we can assume that it's something about adjusting the price they pay for credits. And this right here, you can tell his book is old if you can pay $836 for 15 credits. Jeez. I think, don't quote me on this, but I think Lakeland is 117 per credit. So it'd be like double this. This must be, this example must have pulled information from really old data. Let's look at this. Average cost of tuition in community college. No, I'm just curious about this. 3,000, not yearly. Credit cost is what I want. Average credit cost. $594 is the average. Okay. And now let's look at average credit cost of tuition. Lakeland College. Now keep in mind we live in an area with a low cost of living. So if you live in the district, it is, wow, it's cheaper than I said. So I'm sorry I slandered the college. $110.50 per credit hour. So if you take 15, this is something you should think about as a student too. It's good news. You're paying $300 less per credit hour than the national average. That's just an insane amount because you have to do, for the programming degree, it's 62 hours. So if you do a load of classes at 15 hours at 110.50. So a full semester here is $1,600. It's not an amount of money to you know, this is a lot of money. So, but instead of paying, it's much nicer than paying. What was it? Was it $450 or $540? This is close enough. $8,100, or for the people thinking of transferring or wondering, maybe I should have went to a university instead of Lakeland College. We'll take a look at the prices there. Let's just do Eastern because they're close. And we're not showing the, let's just not look at the average. Let's look at the credit cost. It's easy to find the Lakeland credit cost. Oh, here it is. So it's a little less than 3 times the price if you wanted to go to Eastern. So you're saving a lot of money by taking classes at Lakeland if you plan to transfer. If not, then you probably don't care about the price of credits here. Let's focus on getting you the skills so you can get a job where they'll pay for your college if you want to move on in college. All right. Anyway, it's easier to find I feel like it would be easier to find the cost of community colleges, because usually what we tout is our low price. And then after that, it's, more focused classes. There's not 50 or 100 people in this class. There's only 23 or 26 max. So you're going to get I can give you a lot more individual attention, which reminds me, if you are confused and you're not figuring this stuff out, you need to talk to me. We can do a Zoom meeting and I can walk you through the stuff you're missing. All right, anyway, got way off topic there because of this terrible example. All right, what about accessing the methods and properties from a derived class? So we had the commission employee that extends employee, and we can see that here. So we declare the class, and we use a colon. Always remember your colon. And you put the name of the base class here. So now we have access to the fields. Properties and methods that are public or not private, right? But well, if we want to change them, they have to be virtual, right? And so that's what we're looking at now is overriding. So they have to be virtual in the base class. So they're saying we can assume this get greeting. We could do like 30 more slides in here. They're really making this hard to connect. So I'm glad I'm here to explain it. By looking at the get greeting method here inside of the commission employee class, and the fact that they are using the new keyword here and using the same name of the method, we have to assume that in the employee class, the get greeting method has the virtual modifier, which means it can be overridden. And so instead of doing whatever an employee does when it gets greeting, this is what a commission employee would do. Okay? They add this sentence, I work on commission. The amount of money I make depends on the success of my job, which is a good motivator, but it's also extremely stressful. They don't have that in there, but that's my own opinion. All right, looking at this. If you're really good at your job, commissions are really good. If you're not, it's not as good. Okay. So now when they do the get greeting, you can see that it's not using the original method, which prints out hello, I'm employee number 345, but it adds this, I work on commission. All right. And so that's only going to work because we're creating a new object of commission employee and we're storing that in salesperson. So the variable of salesperson has a reference back to this object we created. And so when I do salesperson.getGreeting, it knows I'm using a commission employee object. So it's going to look for the methods of that, and it'll find getGreeting, which we added here with the new keyword, which it says that the reason they added that is to eliminate compiler warnings. When you override methods, Scott, do you use the new keyword at the beginning of the name of the overridden method? I don't think I've seen that.
You never use new the method. I don't understand.
Yeah, this might be a different version of C#. It may we'll see. If you're using Visual Studio or if you're using Replit, some things might work differently. I'm assuming the version of Visual Studio, I haven't looked at it. So I might have to look at that when we get to stuff that uses that. But if you identify any differences, let me know, and so we can prepare for those, because some people might be using one or the other. And it would be very confusing if it didn't do what it said it's supposed to do in the examples. Okay. Come here. Alright, mailman's here. Okay. The joys of working at home. So what are we looking at here? Okay, accessing base class methods and properties. Okay, we already looked at that. Oh yeah, so we're moving on. So we got a lot of mail. I think you're...
Apparently new allowed you to open non-vertical.
Oh, really? That's weird. Why would they have two ways to do it? It's starting to turn into Ruby. There's probably a reason. Okay. All right. Anyway, the mailman is gone. Okay. 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 I had actually brought this up before. Understanding implicit reference conversions. So if something is implicit, that means it's implied, which is one of the hardest things to understand when you're coding, because when things are implied, you don't explicitly see them. They're not visible all the time, or they're used in a way that, you know, it makes assumptions on what you're implying. Okay, so anyway, every derived class object, so an instance of the class, well, it says that here, specific instance, it says it's every derived class is a specific instance of both the derived class and the base class. That might be a little bit confusing. What that means is you can create well, let's look at the example before I say the wrong thing here. Okay, you can assign derived class object to an object of any of its superclass types. Okay, so if we make, so we were looking at, let's go back to the diagram. All right, so let's go down, let's go back to animal. So say we have animal, and then we have our extending class, or derived class of dog. It's a descendant of the animal class. And we want to look at understanding what this means here. You can assign a derived class object to an object of any of its superclass types. Okay, so if I have, and we'll see why that's useful, but if I have if I'm creating a dog class object, okay, I've got it created, now I have a dog object. It can be stored in a variable that has the type of animal. Let's see if it just says, yeah, to an object of any of its superclass types. So if we make a dog object, it can be stored in an animal, a reference to an animal, a variable that is of type animal. It can be stored in a variable of type organism, because these are its its ancestors. All right, why is that useful? Well, keep that in your back pocket and we'll get there. So C#, it says, makes an implicit conversion from derived class to base class. So this term, implicit reference conversion, that's a mouthful. We'll break that down here. Is more accurate because it emphasizes the difference between numerical conversions and reference objects. Okay. Let's take a look at the example. All right, they do have a good example for this. So remember, we created the employee class and the commission employee class. And in this example, we are creating one employee object here and one commission employee object. Kind of wish they had line numbers on here. All right. And then we're setting the ID numbers using the properties. And then down here, they've changed the display. Oh, they've created a display greeting static method of the main class. Okay. So that makes it kind of like a function. That might just be confusing. So anyway, we don't need an object to use display greeting. But we do want to pass in an object here, and it's requiring an object of the employee type. Okay, so we have an employee object and we have a commission employee object. Which of those, well, I guess it says right here, both an employee and a commission employee can be passed to this method. Why is that, though? Because one's an employee and one's a commission employee. What about these two allows them to be passed in here? If you use clerk, that's the employee object, all right, it's just going to use it, all right. If you use a commission employee here, it will do that implicit reference conversion. So this is what makes it implied, is the fact that you're putting a commission employee object in here, and it requires an employee object. You are implying that you want to convert this reference of whatever you pass in. So remember, it's a reference to where the object is in the memory. It'll change that to it will no longer be a commission employee, it will be an employee. Okay. So why you would do this? Well, you would want to use this for properties and methods that are shared. So if we had, let's say instead of employee, we had hourly employee and commission employee, and those both extended employee. Okay. Well, we want to be able to get the ID number of commission employees and hourly employees. And so we don't want to have to write a separate method for both of those. Remember, don't repeat yourself. So by using the class that contains the field that they have in common here as our type, we can now use this method with any of the descendants of the employee class. All right, and so this is getting into the thick of what object-oriented programming is, understanding polymorphism, inheritance, overriding. This is what object-oriented programming is. Okay, because I don't think in the Python class we kind of look at objects briefly. Python is not a good language to learn objects with, but we do take a look. Other than that, I'm not sure. Maybe you've created objects in JavaScript without realizing it. What other languages have you seen? We got rid of the Java class. Maybe you saw some in there. We got rid of the Visual Basic class. the only languages that you would see coming into the programming program would be JavaScript, Python, and C#. And then if you want to count HTML, CSS, and SQL, you also see those. But in Python and JavaScript's a lot better for objects than Python is. All right, but there's still it's tricky to use objects in a language that does not have typed variables. Because C# is so strict and it requires you to type your variables for the most part, it works a lot better with this because you don't have to. If you try to do something that won't work, it just won't let you. All right. So I'm just going to verbally talk about another example here using implied reference conversion. Implicit reference conversion. Okay, so if we have a reference, say we created a variable of cat. Let's say we create a cat object. So we do cat mittens. So there's our cat type. We use an identifier of mittens. That's the variable name. And we'll assign in the reference to a new instance of the cat class. Okay. And so what is a field that all of these classes would have in common? Well, they all have names, right? So let's think about organisms have names, so these all inherit that property. And we need a method so that all of these classes can tell you their name. All right, so we could include that method in the base class. Is that what they did in here? Did they tell us where they put it? Well, I guess they put it in the main class here. So if we wanted in our main to have each of these types of objects tell us their name, you don't have to go into each one and provide a separate field of name in each one. You can just include that in the organism class, and then when you use a method in your main, you can just use the base type of, in this case they're using employee, that's the base type. Our base type is organism. And so all organisms have a name. All things that descend from an organism have a name. So if we put organism here, we could pass in any of the descendant classes and get their name using one function. We don't have to create a separate function for each class to get their name. And so again, it prevents you from having to repeat yourself, which is a waste of time, but it's also every line of code you have to write is another chance you make a mistake. So there's that. All right, and I think I'm 15 minutes over. We have the next assignment due next week, but let's take a look at it first. Make sure we include all of the parts that you're going to need. Or if we need to go over more next week, we can just push the due date back. This is a very lecture-y chapter, huh? Not much coding to do here. There's a lot of overhead on writing this code, so I'm glad the examples were good enough. All right, so we're in chapter 10. So object-oriented programming 1 should really start in probably chapter 6. And chapter 1 through 5 could probably fit in the first 2 weeks. And that way, you could actually get to classes and objects in object-oriented programming. I'll have to make that change for next fall. Okay. Actually, I can make it in the spring because that's when object-oriented 1 is taught. Okay. Chapter 10, and what was the assignment? It is salesperson on 479. Okay, we're on 479 here. Salesperson demo, I'm assuming that's what it's talking about. Okay. Write a program named salesperson demo that instantiates objects. Okay, we already did that in the last chapter. Using classes named real estate salesperson. We've created classes before, and Girl Scout. All right. You know what? I've never thought of real estate salespeople. Wow, this book was from 2017, and they put salesperson. That's very progressive of them. Real estate salesperson and Girl Scout. All right. I guess they haven't. The Girl Scouts have not. They probably just don't want to give up their brand name here, but. No one's made a big enough deal about that to change it yet. Okay. Write a program named salesperson demo that instantiates objects using these classes. Okay. Demonstrate that each object can use a sales speech method. I think this is going to be the hardest part of this. Is just going to be finding the syntax to use. Okay. Can use a sales speech method. That's not method appropriately. So. In a very vague, roundabout way, they're asking you to what are they asking you to demonstrate that each object can use a method. Also make a sale method. Use a make sale method 2 or 3 times. Okay, oh, they're talking about this is what's going in main. Okay. The sales speech, make sale with the objects you've created. Display that. Okay, that all makes sense. Create an abstract class. Okay, we haven't got to abstract classes yet, so we'll need that. That is, I feel like that's not going to take that long to go over. Let's see what else we have left. Okay, the object class. Okay. I don't think we need to use the. We can go over that later. Okay. We can go over the object class later. Base class constructors. Okay. Looks like it's probably. Here is, so, oh, this is overriding, or no, yeah. Oh, they don't have a very good example of this here either. Okay. I guess this is a good enough example, but it's not really showing you how to be more efficient with it. Okay, so here, well, I guess because they're creating the object and then manually assigning the fields on each line, this makes sense. Okay, so you know, here we have the employee class. Here's the constructor. How do we know this is a constructor? Well, a lot of things can be public. That's not going to identify it for us. Constructor is a method, so we're going to have parentheses for the parameters. In this case, I guess they don't care about what parameters you use. And we have a name here. This name has to be the same as the class for the constructor. All right. And so here, if you construct an employee object, so you create a new employee, so create an instance of the employee class, it will print out employee constructed. And then so is this actually before they do the ones? What was the question I need to ask you a question, Scott. So do inherited descendant classes inherit the constructor of their parent? If you don't specify a constructor, it just gives you a blank one, right? Yeah, I can't. Why are they making a big deal about this? Is it? Do you need that to do abstract?
Base to inherit the constructor of the.
Oh, that's what it is. Okay, that's what I was trying to remember. Okay, so this is just demonstrating different constructors, but I don't feel like. Okay, let's go back and see if we can break this down. When you create a base class and a derived class and make an object of the derived class, you call 3 constructors, one from the object class, which we haven't talked about yet, but I can basically sum that up with just adding one thing to our diagram here. So we've created all these classes, organism, yada yada, but the organism class actually inherits from another object, or not an object, a class called object. All right, so this is the granddaddy of classes. So I'm not going to call this object because that's confusing, but I'm going to call it the object class. It's just the name of it is object, but it's the object class. It's not an instantiated object. And people wonder why this stuff is confusing. It makes sense when you use it, but trying to teach it is can be hard to follow. Okay, so this is what they're talking about with the object class. And the reason we need to go over it is because it has a lot of methods that we can override and use in basically any object. So do you know how, if you're in Visual Studio Code, or I'm sorry, Visual Studio, I guess it would be in Visual Studio Code also, but in Replit, when you type something and you know, an identifier of a variable or whatever, and you press dot, and then it comes up with that giant list of methods, and some of them aren't even part of the class you created. Well, it's pulling them from here. And when you do it down in even further down Descendant, this is going to show you all the methods that you defined in this class, all the ones defined in this class, and this class. So that's why when you're working with objects, and I wonder if it specifies, in the kind of what is it called? Auto fill. I don't know. That's Excel. IntelliSense. Is that what it? That's what shows you all the variables and methods that you have access to from whatever you're accessing. Okay, which is that little pop-up box that shows you everything. It's very scary if you don't understand where that's coming from, but you can understand it. I just, explained it. It's all coming from the ancestor classes. Okay. Or it can be coming from the ancestor classes. Okay, so we'll go over what those different parts of the base class are next time. And you know what, at this point, well, they're only doing one slide on abstract. Let's see if they're making you do the other parts, and I'll decide whether we're going to just, if I'll cut this off. Okay. Included, okay. Da-da-da-da. So we'll create a abstract class. We got to go over that. Create child classes. We know how to do that. Fields. We know that. Field. Make properties for every field. Okay. I guess they want you to do some extra typing there. Creating an interface. Okay. Yeah, we should probably just wait on this. And then implement boxes of cookies. Okay. Yeah, we'll have to do another week on this, just because the content is a little. This is like so important. This is like the basic things that you need to know about object-oriented programming. So if you miss this chapter, or you can't pass this chapter, you're going to have a very rough time. So again, if you are having trouble, this is, you know, the pinnacle of the programming that you're going to get, knowledge that you're going to gain from Lakeland before you go to your career. Other than if you do get an internship, the things you learn there are going to be much more valuable and real-world experience. But you want to have the base knowledge so you can get the internship. Okay, so I'm going to change the due date here. I'm going to put it out another week, which is fine. Let's see if anyone did it already. Doesn't look like it, which is fine. I mean, trying to figure this out on your own, I don't think it would be very easy. So, okay. Oh, we're changing the date, right? Give it another week. That should let me finish up what we need to talk about, and then you'll have a week to work on it. If you want to go ahead and start setting it up with the parts you know, you can save yourself a lot of time, because there's a lot of that. Only the abstract classes part and the interfaces part are important. Or I'm sorry, are the stuff that we need to go over. And yeah, so you could create the classes for real estate person and Girl Scout. Okay. And this is very, I don't agree with this. They want you to, inside of, once you create those classes, call the sales speech method without having made it yet. So they're almost doing this backwards. They're asking you to do it backwards. Use the method and then later go build the method. Have you ever done that, Scott? Have you ever written code in one place referencing methods and classes you have not defined yet?
Yeah.
You have?
Yeah.
Okay.
All the time. I don't understand. If I'm writing something and I know I need a method for it, I'll type it out with the method.
Right, and then you go make it, right?
And then go write the method.
But you don't write the whole program and then go back and fill in everything, right? You do it. That would make no sense. They're asking the students to do that. Okay. Anyway, it'll work this way, but I'm not a fan of this. This is like planning to go on a road trip And then after you know where you're going and stuff, going to learn how to drive. Okay. Anyway, we'll set that to the 29th. We should be able to finish this up next time. Again, I've said this multiple times through the video. Please contact me if you're having problems, because Friday is the midterm verification. At this point, if you haven't turned anything in or participated in any of the classes, I'm going to withdraw you. That will save you a bunch of hassle with financial aid and stuff. But you'll have to either talk to me or retake the class. So if you get withdrawn, people watching this are fine if you turned in your assignments. But if you haven't even finished the last assignment and you haven't contacted me, you need to. All right. I'm going to end it here. How many times have I said that? Okay. I'll see you guys next Thursday. Have a good week.